Greetings to my audience. I'm Cha from Separation Engineering Technology, Section 2 at UTHM. So, today, I would like to share a topic with question related to our Chapter 5, humidification. So, let's look into our question. So, for air at 30 degrees Celsius, which is at dry bulb temperature, and 40% of relative humidity. By using humidity chart, find dew point and wet bulb temperature. So, before moving forward to our solution, let's gain some knowledge about what is exactly dew point and wet bulb temperature. So, dew point basically refers to the atmospheric temperature below which water droplets begin to condense and dew can form, while wet bulb temperature is the lowest temperature achieved by the adiabatic evaporation of water in the air until the air is in saturated form. So, without wasting any time, let's move into our solution. So, we can see based on the graph, there are a lot of lines, but I want you all to notice that the dew point, which is the green line pointing towards the left, and the wet bulb temperature, the yellow line pointing 315 degrees upwards. So, dew point at 30 degrees Celsius with 40% of relative humidity. By using the following formula, which is Fahrenheit equals to degrees Celsius multiplies by 9/5 plus 32. So we can get 30 degrees Celsius is equal to 86 Fahrenheit. By referring to the graph at the intersection point between the 86 Fahrenheit and 40% of relative humidity, we can get the dew point is equal to 59 Fahrenheit. So, about the wet bulb temperature, basically at also the same point, which is the intersection point between 86 Fahrenheit and 40% of relative humidity, pointing 315 degrees upwards, which is representing the yellow line, which is we can see at above there. So, referring the graph, the wet bulb temperature is equal to 69 Fahrenheit.
Hi and good day to sir. I'm Pang Xing Shan from Section 2 of Separation Engineering Technology, and today I'm going to present about the question 2 in our assignment, which is the questions 100 meter cube of humid air per minute enters a heater at 20 degrees Celsius and 60% relative humidity. So by using a humidity chart, calculate the heat required to heat the air to 40 degrees Celsius. So first of all, I draw the mass balance diagram to show the whole process. So in this question number 2, that the value we have to find is the heat required for the whole process or the reactions for this process. So the formula that we use for the solution is Q equal to mass flow rate of dry air times with change in enthalpy. So first of all, we have to find the change in enthalpy. So the change in enthalpy is enthalpy out minus enthalpy in. So for the enthalpy in, the information in the question we get is 20 degrees Celsius with 60% of relative humidity. So for the enthalpy out, the information we get in the questions is 40 degrees Celsius only. So firstly, to find the enthalpy in, we have to draw a straight line from the 20 degrees Celsius from the dry bulb temperature, go up through the x-axis until it reaches the 60% of relative humidity curve, and from the intersection we draw to up left directions until it reaches the scale of enthalpy at saturation to get the enthalpy in. So to remember that our inlet air is not saturated, and it is only 60% of saturation. So we have to account with the enthalpy deviations, which is the curve that beside the intersection point, which is negative 0.1 and negative 0.2. So we take the middle value of it, which is 0.15. So 43 plus negative 0.15, we get 42.85 kJ per kilo of dry air. So for enthalpy out, we do the same thing. We draw a straight line from 40 degrees Celsius up through the x-axis, and before that we have to draw a horizontal line from the intersection point of the first point horizontally to the direction of 40 degrees Celsius, and the intersection point with the 40 degrees Celsius, we draw a same line straight up left to the enthalpy at saturation scale, and we get the enthalpy out saturation value, which is 63. And the same things, we don't have the saturated air, so we have to use we have to account the enthalpy deviations, which to plus with the value in it. And since our value is in the middle of negative 0.6 and negative 0.8, we take the middle value of it, which is 0.7. So 63 minus 0.7, we get 62.3 kilojoule per kg of dry air. So in the last part, we have to conclude it to get the change in enthalpy, which is enthalpy out minus enthalpy in, 62.3 minus 42.85, and we get 19.45 of the dry air enthalpy change. And step 2, we have to find the mass flow rate, which is MDA of dry air. So first of all, the value that we got in the question is the volumetric flow rate of inlet, which is 100 meter cube of humid air per minute. So for the humid volume, the unit for the humid volume is meter cube of humid air over kilogram of dry air. So according to the chart, the first point that we plotted in the first graph, in the first chart, is the 20 degrees Celsius with 60% of humidity. The point can be stated that the humid volume is approximately 0.84 by comparing the two humid volume scale on the graph, on the chart, which is 0.85 and 0.80. And then the formula for the mass flow rate is volumetric flow rate of inlet over the humid volume. So the volumetric flow rate of reaction is 100 meter cube, and the humid volume is 0.84. So 100 divided by 0.84, we got 119 kilogram of dry air per minute. So for the last part of this questions, we have to calculate the heat required for the process. So Q equal to mass flow rate of dry air times the change in enthalpy. So 119 kilogram of dry air per minute times 19.45 kilojoule per kilogram dry air, we got 2315.48 kilogram per minute. So next one will be question 3. So 50 meter cube of humid air per minute enters a heater at 25 degrees Celsius and 50% relative humidity. By using a humidity chart, calculate the heat required to heat the air to 45 degrees Celsius. So first of all, the mass balance diagram is drawn to show the whole process. So it's similar to the question 2. We start with the finding of change in enthalpy. So change in enthalpy is enthalpy out minus enthalpy in, which the information that we got from the questions for enthalpy in is 25 degrees Celsius and 50% of relative humidity. So for enthalpy out, we got 45 degrees Celsius. So to find the enthalpy in, the first thing we do is same with the question number 2. We have to draw a straight line from 25 degrees Celsius from the dry bulb temperature up to the x-axis until it reach the relative humidity curve of 50%. So from the intersection, we draw up left to the enthalpy at saturation's scale. So the enthalpy in we got is 49. So due to this case is not fully saturated, it is only 50% saturations, and we have to count with the enthalpy deviations, which our point is stay between negative 0.2 and negative 0.4 of the enthalpy deviation. So we took 0.3, which is 49 minus 0.3, we got 48.7 kilojoule over kg of dry air. So for the enthalpy out, we have to draw a horizontal line from the intersection point, first point, to the right, and we have to draw 45 degrees Celsius up from the dry bulb temperature until it reaches the horizontal line we drawn from the left. So from the intersection, we draw it to left until it reach the scale of enthalpy at saturations, and the value we got is 7.771. And to get the accurate number, we have to plus with the enthalpy deviations, which is stay between 0.8 and 1.0. So we took 0.9 as the enthalpy deviations. So 71 minus 0.9, we got the 70.1 kilojoule per kg dry air. So to get change in enthalpy, 70.1 minus is 48.7, we got 21.4 kilojoule per kg dry air. And for step 2, we have to find the mass flow rate, and the info we got is volumetric flow rate inlet 50 meter cube of humid air over minute. So to get the humid volume of our point, that is our point is stay between 0.85 and 0.90. So the humid volume, after we compare with two lines, we got is 0.86 meter cube of humid air over kilogram of dry air. So to find the mass flow rate, we have to use the formula that volumetric flow rate over the humid volume. So 50 meter cube over 0.86 meter cube of humid air over kilogram of dry air, we got 58.14 dry air per minute. So lastly, to find the heat required for these processes, mass flow rate times it change in enthalpy. So 58.14 times it 21.40, we got 1244.2 kilojoule per minute. That's all for me. Thank you.